We're going to get into our next naming system, but before we do that, there are a few loose ends that I want to tie up. So there are 5 of our polyatomic ions that I want you to memorize, okay? And the reason for this is because they are very common polyatomic ions, and it's just best that you just know what they are and what their charges are, so you don't have to worry about looking them up all the time, because they're very common. So these 5 polyatomic ions are the ones that I want you to memorize. So PO4 with a 3- charge, which is phosphate. NO3 with a 1- charge, which is nitrate. SO4 with a -2 charge, which is sulfate. CO3 with a -2 charge, which is carbonate. And OH with a -1 charge, which is hydroxide. Okay, so put that on your list of things to start memorizing. Okay, another loose end thing that I want to take care of is with naming, there are some things that you should start paying attention to, and that is the endings of negative charges. Right now, we have 3 negative charge endings to pay attention to, and that's an ide, an ate, and an ite. And you need to be aware of where these come from. So if you think about ides, in the name of NaCl, NaCl is sodium chloride. There's that IDE ending. KBr is potassium bromide. There's the IDE ending. MgO is magnesium oxide. There's the IDE ending. So what do all of these have in common? What they all have in common is that they are just 2 elements. They're a positive ion and a negative ion, or a metal and a nonmetal. So ides refer to compounds with 2 elements. Okay, so that's the first thing. Now, looking at your ates and your ites, these are referring to compounds that contain polyatomic ions. Okay, so you want to start becoming familiar with those types of things. So if I have SrCO3, okay, that is strontium carbonate. Okay, so there's your ATE ending. If I have NaNO2, that's sodium nitrite. And there's your ITE ending. So you're just going to want to start becoming familiar with those, so when I give you names like, let's see, potassium nitride, okay, versus potassium nitrate. Okay, so if I have those 2 compounds, what distinguishes the difference is an ide versus an ate. Potassium nitride is K3N. Potassium nitrate is KNO3. So that's why I want you to start becoming familiar with those things. Okay, now, keeping all that in mind, we need to jump to a new naming system. And one of the things that you hopefully have noticed on your worksheets is I have not given you any transition elements. Okay? Transition elements have multiple charges due to the various ways they can lose electrons and become stable. So because of that, that creates a problem. And the problem is both of these compounds, CuCl and CuCl2, exist. But under our current naming system, we only have one way to name these. Okay? Calling these both copper chloride does not work because they are two completely different compounds with completely different physical and chemical properties. So we need another naming system. And the naming system that we're going to look at is an old naming system. It's called the classical system. And it is an old naming system. In fact, it's being phased out, but we still have to learn what it is. So in this old naming system, what we're going to do is we're going to add endings again, but we're going to add those endings to metals, which means we're adding them to positive charges, positively charged ions. Okay? So, and the endings are going to represent lower or higher charges. So the first thing we're going to do is, first ending we're going to add is we're going to add an OUS ending for the lower charge of a positive atom. And what I need you to do is actually go look at your periodic table and look at copper. Okay? And if you look at copper, copper can be a +1 or copper can be a +2. So what we're going to do is we're going to add an OUS to represent the +1 charge. And then we're going to add an IC ending for the higher charge. So we're going to add the IC ending for a higher charge copper atom. Okay? And oh, by the way, we're going to use their Latin names as well. Okay? For this. And what I mean when I say we're using their Latin names is if an element has a symbol like Cu, which is from the Latin name, then we're going to use the Latin name of that. If the symbol is an American name, then we'll just use the OUS and IC ending on the American name. So this is where this comes into play. So we have CuCl and CuCl2. So one of the first things you're going to have to do is you're going to have to figure out what is the charge of these two coppers. And what I'm going to say from now until the end of this chapter is use the negative charge to determine the positive. Okay? Use the negative charge to determine the positive charge. So chlorine on our periodic table is -1. So this copper, in order to balance that out, needs to be +1. And over here, chlorine is still a -1, but we have two of them. So this copper has to be a +2 to balance that out. So that means this copper right here is the lower charge. So what we're going to do is take the Latin name for copper, which is cuprum, okay, and we're going to add an OUS to that ending. So this becomes cuprous chloride. And for this one, we're going to add the ic ending, so it becomes cupric chloride. Okay? So it is going to be helpful that you know what the Latin names are. But if you take out your polyatomic ion sheet, and I wish I would have put that in here, but on the right side of your polyatomic ion sheet. So here's your poly sheet, okay? In this right-hand column, right over here, what you're going to see is classical names. Okay, and that's going to help you know what the names of these charges are. And yes, you get to use this sheet for the test, but that's going to help you with the classical, knowing the classical names. So if I go to these two, FeBr and FeBr3, again, I need to figure out what the charges are of those two ions. So Br is a -1, so Fe has to be a +2, because right here I have two -1 charges. And then this Fe here, okay, since Br is still -1 and I have 3 of those, that's a +3. So if I look at my periodic table, I can see that +2 is the lower charge, +3 is the higher charge, and it would help if I knew that the Latin name of iron is ferrium. Okay, that's its Latin name. So I'm going to add the OUS to this one, and I'm going to add the IC to that one because it's a lower and higher charge. So this name becomes ferrous bromide, and this name becomes ferric bromide. And notice I'm not doing anything to the negative ion. We are still using the previous naming rules for the negative ion, which is to add the IDE ending. Okay? Now, what's going to happen when you have something that doesn't have a Latin name? Like nickel. Okay? Nickel does not have a Latin name. I actually think I have a wrong charge of nickel up there. Yep. This compound right here I'm going to completely change, and I'm going to call it NiCl3. Okay? So this nickel in this compound is going to be what charge? And if you use the fact that oxygen's -2, that means that's a +2. This nickel right here is going to be what charge? And since that's -1, that has to be +3. So again, I have my lower and higher charge. My lower charge is OUS, so I take nickel and I put OUS on it, so I get nickelus. And then this one is the higher charge, so I've changed this now, so it's going to be nickelic chloride. Okay? So you have your lower and higher charges, and that's all this naming system is. So again, if you look on this on your polyatomic ion sheet, you're going to get all of the classical names right here. Okay? If you have questions, then please stop in, because I can do a couple more here. So again, this is huge. Use the negative charge to determine the positive charge. So if you think you have this figured out, then go ahead and start the worksheet and stop watching this. But I will do a couple more here just to help us. So nitrogen here is a -3 charge. And so this chromium, okay, because I have two -3 charges, must be a +2. Okay, the other thing is I can bring these charges up. So that +2 is the lower charge. So this becomes chromos, okay, because it's the lower charge. And then nitride, because I'm just adding the nitrogen to it. Okay? Not doing that one. So again, here's nitrogen. Nitrogen's a -3 charge. So that manganese must be a +3 charge. And so +3 is the higher charge. So this is manganese. I'm sorry, manganic nitride. Okay? But then you also have to be able to take the formulas and write the names. Okay? So you going the other way, you have to recognize that, oh, that's ick, so that means that that copper is the +2, Bromide is a -1. So to write the formula, it is CuBr2. Okay? To find gold, which is aurorus, okay, aurorium, excuse me. And gold can be a 1 or a 3. So auroric is the +3 form. Oxide is a -2. So it's Au is a +3. Oxygen is a -2. So bringing charges down, Au2O3. Okay, stannous. This is tin. Tin is atomic number 50, and tin can be a +2 or a +4. But again, if you don't know, look on the right side of your polyatomic ion sheet. That will tell you that tin is a +2, selenide is a -2, so this just becomes SNSE. So, work through your next worksheets.